So open a new document. So you can just click this little 3-bar thing, and you can go new blank graph. All right, let's title it right away, number 57, and call it tasks. It's fine. There we go. All right, just like before, we'll add a folder for number 1 and add the data. I'll give you a second to get all that data in. So the next thing you'll see that's kind of an issue is that if you try to zoom out, since these are in the thousands, and you just zoom out using this, it'll just look like they're all lined up in a vertical line. So you want to manually adjust the scale here. So you can see how the x's only go from 0 to 6. But when you just zoom out like this, it zooms out both of them the same. So this is zoomed out to thousands, but we only want the x to really display like 0 through 6 or 0 through 10, just to make it even. So what you're going to do is go back to these graph settings on the wrench here. Go back to here. And then right here you can actually type in manually where you want the x to start and stop. So for this table it starts at 0, so I can change that to 0. And I want this to stop, I'm going to say 10. Right? And the y also starts at 0. And I'm going to make it go up to, I think the highest is 5,000 or so. So I can go up to maybe 6,000. Right? And you can see that the data now, since I changed the x and y axis here, I changed those to fit my data. Once I click off it, it'll actually display a lot easier, and it'll look, okay, those are pretty good. Those are on a nice straight line pretty much. My correlation should be high. My correlation should be negative because it's going down. So that's the way you change the window to make it look so you can actually see your data as it's supposed to be seen. So now we can go down here and do the correlations, see what my equation is. Okay. So here, my R is going to equal, negative 0.929, which is the same as 92.9% accurate, which is really high, remember. Notice how I did not care about the negative. So the negative doesn't really matter. It's the number that's important, and it's a percentage. So the higher the percentage, the better, right? Because this line, it's pretty accurate. It's spot on. If you follow it down, it's spot on for several of these spots, and it's really close to the other ones that are not exactly on the line. So it's a really good, accurate line I could use to make some predictions with. Let me add another note, and I can go through these, and I already did B, and so I can actually write out C now. And it asks me, what's the equation of the line? And we can take the M and the B from right here and write my equation of the line. So I got y equals, I like to put a space with the equal signs, space it out a little bit. So negative 500x, space plus space, 5,000. So there's my equation of my line. I'm going to put it down here below. So I'm answering number C. That's on your worksheet there. Okay. Then I can add another note and put in what D is. So you always do a note when you just want to type a response. So number D says, what is the y-intercept? So I'm going to start off with, B equals 5,000. Right? And what does the y-intercept mean in context of the problem? So what does this y-intercept mean? 5,000 what? So what does these numbers stand for? Remember, if you look at your table there, that's dollars. So what does it mean for 5,000 right there, 0, 5,000? So the 0 stands for how old it is. So if it's 0 years old, that means it's brand new. So basically what they're saying is that brand new scooter costs $5,000. $ 5,000. So it's important to know what the number is, but the computer just gives it to you. You have to know what it means. That's what your job is as a statistician. The computer will usually give you all the answers, but if you don't know what it means, if you don't know, like an R, 0.929R means 92.9%, okay, it doesn't matter they give you the answer. You don't know what it means. Same thing here. If you get a y-intercept of 5,000, if you don't know that means 0, 5,000, 0 years old, $5,000, it's kind of meaningless. So same thing for E. Oops, I got to add a note. So we got E, and the slope is negative 5,000. Negative 500. And what does a negative 500 slope mean? So remember, the slope is going to be rise over run, so it's actually negative $500, okay, per year. Okay, which means the value of the scooter goes down $500 per year. And the fancy word for that, and you'll hear this at some point, is depreciate. That means loses value. Okay. All right, so let's continue and look at add another note and look at F. Okay. So it says estimate the value of the scooter that's 9 years old. So let's move this. Click on your line, and let's move this to 9, where x equals 9, and see what the value is. Here's where you can use your line of best fit to predict. So I can take this all the way down to here. There it is, 9. And you can see, oh yeah, 9 years old, it'll only be worth $500. So based upon what we already know for 5 or 6 years, I can predict now all the way up to 9 years that, oh, if it keeps going this way, it's only going to be worth this much. It's only going to be worth, what is it, 500? Yeah, only worth 500. So for here, let's say something. After 9 years, the scooter will only be worth $500. And if you wanted to, you can do the next line. You can actually plot the point 9, 500. Don't do a note, but do an actual, expression, and you can type in the coordinate 9 years, $500, and you'll see it right there on your line. And I could change the color if I wanted. Whatever you want. You can add another note, and now do G. Okay. So when will the scooter have a value of 1,000? Okay. All right. See you. Scooter will have a value of $1,000. The right sign. After, let's see how many years. So I'm going to go back to my line here, and let's see, where is 1,000? Now I'm looking at the y value, right? So here's the y value. It's 4,000. It's 400. So I'm going to move this until it's exactly 1,000. And then you can see right about there at 8. So after 8 years, that's when it'll be worth $1,000. Okay? After 8 years. And if you want, you can plot that point as well. 8, 1,000, and it should be on your line. So there's all our predictions. We did the y-intercept when it was brand new. It cost $5,000. We found that after 8 years it cost $1,000. After 9 years it cost $500, which makes sense because according to the slope, right, E, it's going down $500 a year, so it makes sense after 8 years if it's $1,000. Well, 9 years, a year later, it'd go down $500 because it's going, that's the slope. So everything you should kind of agree with it. Agree with its, okay? All right, so anything else? Oh, H, one more. So let's add one more note and do H. Okay? Describe the relationship between the scooter's value and its age. Probably the most important question on here. So what does this all mean? So what? What does this tell you about the price or the cost or the value of a scooter over time? In general. As general as you can think. Okay. And it's more obvious than you think. The value of the scooter, does it go up or go down? Over time. Yeah. The value of the scooter goes down over time. So eventually, if this thing's old enough, like once this scooter is 10 years old, how much is it worth? Nothing. Yeah, you can't, it goes to the junkyard because unless somebody wants to buy it for parts, it ain't worth anything anymore. So yeah, so the scooter will lose value over time. It's not going to gain value. That's basically all they're asking there. It's simple to read, but it's sometimes difficult to come up with, well, what does this mean? It just means, yeah, scooters and cars and vehicles in general lose value over time. They never quite equal zero. You can always sell it for something, but definitely not what you bought it for. Whatever you purchased, that's probably the most expensive it's going to be. Unless it's going to be some super classic car that's very rare, like some of the 60s muscle cars, Jaguars and Corvettes, you know, that they only made 100 of them, you know, back then, so there's only like 2 of them that exist now that actually run. Those will actually go up in value, but a general car of everyday purposes, not going to get a lot of money in 10 years for it. It's just going to go down only. Okay. So the only exception to that rule would probably be, you know, very classic or rare cars. So let's go ahead and just move each of those into the folder. Okay. And use this as an example to do the backside, the hockey problem. And this is a closer way, if you're thinking about mathematics and jobs and things like that, this is really a better way of looking at it. You're not going to go to some job, they're going to give you a worksheet, say do these 5 problems. You're probably working on a computer figuring out some single problem that might take you, you know, an hour or a day or a month or a year. Okay, it's not just paper and pencil usually in, you know, world. You have to learn it there so you know how things work, but in the end, once you know how it works, you just put it in the computer, it'll tell you what the answers are, and you have to figure out what to do with those and what they mean. Okay? So if you're thinking, I like the math, but I always make small mistakes and things like that, not the worst thing, because in the long run, you're not going to be actually calculating things by hand. You're going to be trying to interpret it and see what it means. Okay? Go back to your boss and say, oh yeah, I got a line of best fit, and it's like 93% accurate all the time. That's what's important. Okay? All right, so I'll let you guys go ahead and do the next one. Go ahead and submit the link right now, so whenever you work on it and finish it up, I will already have your link. So since we don't have a lot of time, just go ahead and make sure you save it, right? And then go ahead and share the link. Put that link in your locker and turn it in under today's date, number 57, so I have it. And that way you can go back and finish it later today or for homework tonight, and I'll have it whenever you turn it in. Okay? All right.